two types of statistics. The first is descriptive and the second is inferential. So descriptive statistics are basically ways of summarizing the data. When you have a whole bunch of data given to you, it's often too much to actually deal with. It's difficult to understand what's going on. We've just got pages and pages and hundreds and thousands and millions of bits of data. So if you could summarize that data and organize it into a chart or a table, or say, for example, find the mean of that data, it's easier for you to understand or get an idea or get a handle on what's going on. So that's all descriptive statistics is. It's ways of summarizing or describing the data in an easier format, a format that's easier to understand. So the next type of data was inferential data, or inferential statistics. And before I get into that, let me give you a little example. Back in the day in England, this is the population of England. So back in the day, there was a big problem. There was no welfare state, and there was a lot of people that were actually working in very dangerous jobs. Not really much health and safety, and a lot of people would die at a fairly young age. So the problem they had in England was that if somebody died, say a 30-year-old guy who was married and had a couple of children, if he died before he got to 40, before his kids could actually go out and actually get a job, there would be a lot of hardship for that family, no welfare state, and a lot of the time they would end up on the street or in something called a poorhouse. So some businessmen actually realized that this was a problem of their times, and they set about solving this problem, but at the same time making some money for themselves too. So for example, what they did is they actually had a book, and they called it a rating manual. This is a book here, and it's got lots of entries in it. And basically this book, they would look at it, and if there was a guy who was 30 years old and he was concerned that he might die and leave his family destitute before he got to 40, they would look up in this book, okay, there's a guy, he's 30, he's concerned that he may die before he gets to 40. So what we're going to say to him, if you die, then we're going to go to your family and we're going to give them £1,000. I'm obviously making these figures up, for example, but this really did happen. They're going to give the family £1,000. So the family, £1,000 was a lot of money. The family would be okay financially. And then they wanted to make money. So they said, for example, we're going to actually charge you a premium of, say, £1 per week for that. So they were making some money out of it as well. Now, of course, if he didn't die, all these £1 they collected, they get to keep. And if he did die, they'd have to pay that money out. But there was many people that they would give this coverage to, and so they were collecting a lot of £1, and not everybody would die. And they had people called actuaries that would actually work this out for them, how much to charge, and so on. So they did that. Then they looked at the population of Scotland, and again, so they basically offered them the same type of deal. They said to the guys in Scotland, okay, here's the book for Scotland. So this is the population of Scotland. And so they said, okay, they had lots of numbers in there. So again, if there was a 30-year-old that was concerned that he was going to pass away before he got to 40 and leave his family in trouble, and he was going to get £1,000 if that happened, these businessmen said, oh, we're going to charge you, for example, 75 pence per week, even though they didn't have pennies back then, but whatever the currency was. And we may look at that and say, why were they charging the population, the people in Scotland, why were they charging them less money than the people in England? And the answer for that would be that there was a lower chance that this guy would die before he got to 40, because in Scotland they were more into farming, and the atmosphere was still cleaner. They weren't burning as much coal like they were in England, and so that's why they're charging the population of Scotland a lower rate than the population of England. Now, the word population back in the day, it really did concern the population of England or Scotland of a country. But the word population now is just whatever I'm interested in conducting an experiment on. So population is, well, let's take an example. Supposing I'm trying to find the average height of students at this university, and I just want to find all the students and add their heights up and then divide by however many students, and I'm going to get the average height. But because I'm interested in the students of this university, that is what my population would be. Now oftentimes it's very difficult for me to get to all the students of a whole university. Some universities have 20, 30, 40, 50, 60,000 students. So it's going to be difficult, time consuming, cost a lot of money to try to get to everyone. So what I can do is choose a sample of students. And so long as that sample of students is a good representation of the whole group. So this sample in here, if it's a good representation of the whole school, I can actually work out the average height of the sample. And supposing the average height of the sample is going to be 171 centimeters. Okay, that's the height of the sample. What I can actually do is use that as an estimate of the population average height. Now, it's not going to be correct. It's just going to be an estimate of what's really going on. But if we choose this sample so it's fairly representative of the whole population, then this estimate should hopefully be fairly good. And as we move on through the course, we're going to find out that there's more than one way of estimating this, and we can actually add a degree of accuracy or increase the accuracy of the estimate. So now, when we actually do this, when we actually want to find out the population figure, but it's too difficult to get to everyone in the population, so we actually choose a sample and find the sample figure and use that as an estimate of the figure that we really want. That process is called inferential statistics. Okay, and I'll come back to that as we go through the slides again. But let's look at an example now. So let's move on to an example. Oops, too far. Okay. Okay, here's an example here. Using a survey of a random sample of 5,000 California residents. So 5,000 California residents. A UCLA economist told a local TV station that over 55% of Californians, all Californians, have a positive view about the future of the US economy. And is that, what sort of statistics is that? Would that be descriptive or would it be inferential? Well, see, what we've got for question one is this guy, this is the whole population of California, and this guy took a sample here of 5,000, and he had figures for the sample of the 5,000. He did not have figures for the whole of the population, and yet he found out that 55% of the sample had a positive view. So 55% of that sample, of this sample, had a positive view. He didn't test the whole of California, and yet the claim is about Californians, all Californians. So this would be an example of inferential statistics, because he really wants to find the figure for the whole population, but he's using the sample figure and he's implying or inferring that it's going to be, he's not inferring that it's true, but he's using it as an estimate for the whole population. So that is a classic example of inferential statistics. How about the second one? Say from a survey of a random sample of 5,000 CSUF students, it has been learned that 80% of those sampled are very excited about studying statistics. So in this case, they just looked at 5,000 students and they only spoke about the 5,000 students. 80% of those sampled. So it's only talking about the sample. He's describing the sample. She's describing the sample. Okay, they're not trying to extract the result, the 80%, and apply it to all students in that school or all students in America or all students in the world. They're just saying, look, we looked at 5,000 and these are the results for those 5,000. So let's move on. Okay, let's just move on the other direction. Population. So population, as we said earlier, the population is the, let's do that a bit bigger. The population is the group of everything that I'm interested in running an experiment on. So this would be my population here. This is the big population. Okay. Now, if I want to find something out about the population, like the average height of the population, and we're going to cover this again later, but the average of a population has a special figure, which is a Greek M, and we call it mu. And I think it's spelled right. It's a Greek it's an English version of a Greek spelling. So most books spell it like that, mu. So mu just means the mean of a population. Okay. So if I want to find out something about the population, like for example the mean of the population, in fact any characteristic of the population, not just the mean, the average. So if I'm talking about, I want to find the average height of all the students that come to this university, this would be the symbol I use for it, and that symbol will be called a parameter. Okay, so a population parameter is anything that describes the whole population. So when any figure that talks about the whole population is called a population parameter. Now, with inferential statistics, even though we want to find out whatever this figure is, we don't have access to all the information. So typically we choose a sample. And in this case, if I'm trying to find the average of all students that come to this university, I don't have access to them. I'll pick a sample of students, which is hopefully is representative, and I'll pick out the average of the sample. Now the average of a sample has this symbol like this. It's an X with a bar on the top of it. So X bar is the average of a sample. And anything that describes a sample, like the average of the sample, the mean of the sample, is called a statistic. Okay, so anything that describes the sample is called a statistic. Anything that describes the whole population is called a parameter. So if we were actually carry on with this exercise and say, okay, the average height of my sample is, say, for example, 171 centimeters, I can use that as an estimate of the population figure. And again, that is exactly what inferential statistics is. This is the actual figure that I want, the population figure. Don't have access to all the population data, so I find a representative sample, find that same value, in this case average height, but for the sample, and use that as an estimate for the whole population. And by the way, this type of estimate is called a point estimate because it's a single point or a single value that I'm using to estimate the population figure, the real figure. Later on, we'll see, apart from just having point estimates, you can have an interval estimate, which basically says, I think that the average height of students is not 171, but I think it's, say, between 160 and 180. Okay, and we're going to look at that. This can be an interval estimate or a confidence interval estimate. Okay, so moving on. Okay. What's the purpose of inferential statistics? Well, the purpose of inferential statistics is to make a inference for the whole population based on a sample, as we just did in the previous example. So let's look at an example. Example 1. According to ABC Consulting, a made-up company that does not exist, the average age of viewers of American Idol is 23 years. But the producer of the show thinks that the average age is higher than 23. To test her hypothesis, the producer of the show samples 500 Idol viewers and determines the age of each. Now, this question is a cool question, because a cool example, because it's actually alluding to something we're going to do later on in the course. At this point, it may seem a little bit weird, but it's talking about something later on. But we're not going to do the later on stuff now. We're just going to look at what we've covered so far and apply it to this question. But what do we have? They're interested in looking at all American Idol viewers, okay, but they've only taken a sample of 500 viewers. So they want to make an inference about this is all idle viewers. So all American Idol viewers. This is all American Idol viewers. That's my population. But they actually looked at a sample of n equals 500. Okay, then they could ask us a few questions. Describe the population. Well, what is the population? The population is all American Idol viewers. There you go, that's the whole population. Describe the variable of interest and possibly the parameter of interest. Well, the variable of interest, what I'm really interested in working out is the average age of the population of all American Idol viewers, and that happens to be a parameter as well. So the variable of interest and possibly the parameter of interest is this thing up here, okay, the average age of all viewers. That's what I'm interested in finding, okay. Describe the sample. Well, the sample is just the 500 people that they took in their sample. And D, describe the statistic. Now, a statistic is anything that refers to, let's go back, not what doesn't want to play with us today, the mouse that is. So the statistic, okay, is something that talks about the sample. So the statistic is something that talks to us about the sample. How far did we just jump back there? Oh. Let's just go back to find our place. Okay, so we had to go back a couple of spaces, but the statistic is something that describes the sample. It came from a couple of slides ago. And so the statistic is the average age of the sample. So what I'd actually do if I'm going to solve this is find the average age of the sample, whatever it happens to be, supposing it's, I don't know, 24. And I'm going to use that as an estimate of this guy up here. That's part of inferential statistics. That's what inferential statistics is. So that's what the statistic is. And what is the inference part, D? The inference is the estimate of the average age of all viewers gained from the sample. So I'm inferring from the sample what the population figure is. And that is what the inference is. Okay, so these are the answers that should be here on the next slide. Let's go to the next slide again. It's just explaining what we've already done a little bit more. And let's look at example number 2. Example number 2 says an airline company is interested in the opinions of their frequent flyer customers about their proposed new routes. Specifically, they want to know what proportion of them plan to use one of their new hubs in the next 6 months. They take a random sample of 10,000 from the database of all frequent flyers and send them an email message with a request to fill out a survey in exchange for 1,500 miles. So what have we got here? We've got, this is all frequent flyers, all frequent flyers. So we've got a list of all frequent flyers in here. This is our population that we're looking at. So I'll just put all frequent flyers, and they actually have a sample here of 10,000. The sample size here is 10,000. So describe the population. The population is all frequent flyers. Describe the variable of interest and possibly the parameter of interest. Well, the variable that I'm interested in finding, that they're interested in finding, is the probability that they will use the new hub in the next 6 months. Okay, what proportion of them plan to use one of their new hubs in the next 6 months? So that's what they want to find, but they want to find it at the population level. So the proportion of people out of everybody that will use one of their new hubs in the next 6 months. So that's part B. C is the sample. Well, the sample is just these 10,000 people in here. And D, describe the statistic. Now the statistic is any value that refers to a sample. So that is a statistic. In fact, the sample size is a statistic, but the one that they really want right here is the sample proportion. Now the sample proportion is a P with a bar on it. We're going to cover this again later on in the course, but they want to find the proportion of the sample that will use one of the new hubs in the next 6 months. And what they're going to do, once they find that figure, they're going to use it as an estimate for the whole population. So the statistic is that they're interested in is just a proportion of people from the sample that will use one of the new hubs in the next 6 months. And the inference, part D, the inference is we're making is saying, well, the sample of 10,000 has a proportion of whatever it comes to that's going to be using the new hub in the next 6 months. And I'm going to infer that that's going to be an estimate of what happens for the whole population. So on the next page, there's some answers there. And here, this example is just alluding to something we're going to do later on in the course. We don't need to worry about it too much for now. It's talking about interval estimates. I briefly mentioned it a couple of slides ago.